Hi everyone, let's talk about properties of triangles here. So triangles, tri is a Latin prefix for three. So a triangle is any polygon or shape with straight lines like this that has three edges and three angles. So, or edges and lengths are kind of considered the same thing here. So this is an edge, this is an edge, and this is an edge. This is an angle, this is an angle, and this is an angle. And that's how we draw angles, is we just kind of draw like a curved looking kind of sector of a circle between, and this is called a vertex. Okay, so or the vertex. So vertex, or point. This is the angle, and instead of using edge, I like to use the term leg. So this is the leg of the triangle. This is an angle, and this is the vertex or a vertex. Okay, so now that we know that every triangle has three sides and three angles. And an interesting property of triangles is that all of their angles, right, all of their interior angles on the inside of the triangle, they add up to 180 degrees. Okay, so before I go into that, a degree is just a measure of like the kind of the distance, the separation between two straight lines. So an angle here, right, we have a straight line here, we have a straight line here. The angle between them is just this part right here, and degrees measure how far or wide this distance is. Okay, so a bigger angle would be if the lines look like this. A smaller angle would be if the lines look like this. So the distance between them is small here, and the distance between them is big down here. Okay? A right angle is when we have two straight lines that are what's called perpendicular. So perpendicular or right, or it's also called normal, is when two straight lines are perpendicular and they kind of, one's going straight one way and the other one is completely opposing it in the exact opposite direction. Okay, so there's often like kind of a half a box drawn right there to show that it's a right triangle. So this means it's 90 degrees or a right angle. So a right triangle is any time we see a right angle in a triangle. So anytime we see 90 degrees in a triangle or this half box looking thing, we know it's a right triangle. And another cool property of triangles is that all of the angles inside add up to 180 degrees. So let's say we knew this was 90, right, because of this half box. And we knew this was, let's say it's 30 degrees. I know it's probably more like 40, right? We know this is 90, I'll just write it in. If we know that, we'll call it angle 1 plus angle 2 plus angle 3 equals 180 degrees. Let's say this was angle 3. How could we find out that angle 3? Well, we know that angle 1 and 2 are 90 and 40. So 90 degrees plus 40 degrees plus our angle 3 is going to equal 180. So that means that this 90 and this 40, they account for, well, 90 plus 40 is 130, so 130 degrees of the 180 degree triangle. So that means that this last angle, A3, is 180 degrees we must have total minus the 150 degrees that the other two angles already account for. Or sorry, this isn't 150, this is 130. 130. So this is going to be 50 degrees. So angle 3 is going to be 50 degrees. So kind of the wider separation between the two straight lines, the bigger the angle you're going to get. Okay? So that's how you can find angles with triangles. Another notation with triangles is that, let's say these two side lengths here, or these legs, we'll call them A and B. Let's say they're the same length. So let's say that this is called the hypotenuse. This longest side here, I'll write it out. Hypotenuse. Okay, that's this part right here. But let's say these two legs A and B are the same length. The way we can denote this is a line through each of them, a single line. Anytime you see the same number of lines through a leg of a triangle, that means they're the same length. And since this hypotenuse isn't the same length, we're going to draw two lines through it. We could do the same thing if we drew one line through this one and two lines through A and B. This is the same thing as long as these are the same number of lines through them. We know they're going to be the same length. Okay, now let's go over the different types of triangles. So there are three types of triangles: isosceles, isosceles, equilateral, and scalene. So isosceles, let's see if I can remember how to spell this right. This is when two of the side lengths are the same length, but one is a different length. So let's say we had a triangle like this, where this was a length of 5, this is a length of 5, and this is a length of 4. So see how these two are the same length, but this one is a different length? If two of them are the same length, then that means they're going to be, or it's going to be an isosceles triangle. It's the same thing with angles. If this angle was 80, this angle was 80, that means this angle would have to be 20. But if two angles are the same, that also means it's isosceles. Okay, let's talk about equilateral triangles. Equilateral is when, I'll write it out here, equilateral triangles are when every single side length has the same length, has the same value. So they're kind of easy to detect, right? Equilateral, let's say this was 10, this was 10, and this was 10. And also, all of these angles inside are going to be the same length because they're going to be the same value because the length of the legs are all the same length. That means that the angles kind of subtending them would also have to be the same, because if any of them were different, one of them wouldn't be 10, it might be like 13 or something. So for equilateral triangles, since we have A1 plus A2 plus A3, plus A3, so the sum of all of our angles has to equal 180. Well, A1 is the same as A2, which is the same as A3. So essentially we have 3 times A1, that's going to equal 180. So if we divide by 3 on both sides, A1 is going to be 60 degrees, 180 over 3. So if A1 is 60 degrees, our first angle, we also know that this is 60 degrees and this is 60 degrees. So for every equilateral triangle, every angle inside is 60 degrees. So equilateral triangle, all the angles and all the side lengths of that triangle are the same. Okay, the last type of triangle is called scalene. Scalene, you probably guessed it, is when none of the angles or side lengths are the same. So this is probably the most common type of triangle because the world isn't perfect, right? You're not going to get like an equilateral triangle in every word problem. So this might be 10, this might be 6, this might be, I don't know, 13. Okay, so none of these angles are the same. This might be 30 degrees, this might be 110, and then this last one would have to be 40 degrees. So there's no uniformity here. Nothing's the same. It's always, there's something different. Like the 10, the 6, and 13 are all different. 30, 110, and 40 are all different as well. Okay, and inside this triangle, let's just talk about these angles here. Right, this angle right here, we said it was 30. This is called an acute angle. An acute angle is an angle that's less than 90 degrees. This right here, and we said it was 110 degrees, just as an example, this is called an obtuse angle because it's more than 90 degrees. Okay, and let's say we were looking at, like, this was 40 degrees. Let's say we were looking at the angle from here on the outside to here. This is called a reflex angle, and a reflex is greater than 180 degrees. So 180 degrees is just a line. So this angle right here, this is 180. Okay, so a reflex angle is kind of a bigger angle than just a straight line. So anytime you see like an exterior angle or an angle on the outside of the triangle, it's usually a reflex angle because it's almost a full circle and it looks kind of weird. Okay, a right triangle, we just talked about it. Right is equal to 90 degrees. So that's when you have two things that are perpendicular, and it kind of forms like half a box right here. So this is when it's 90 degrees. This is called a right triangle. Okay, let's get into some examples here. Find the missing angles of the two following triangles. So see how in the first one, all of these have one line through them? That means that the lengths of the legs are all the same. And remember, this is an equilateral triangle. So for equilateral triangles, all of the legs have the same length. And when all of the legs have the same length, that means that all of the angles have the same value. And for any equilateral triangle, we know that the angle subtending each kind of two legs that are the same length are going to be 60 degrees. So x is 60 degrees, y is 60 degrees, and z is 60 degrees. And if we want to check that these add up to 180, we can just add them together. So we can add this, we can add this. So this is 120 plus 60, perfect, that's 180. So these add up to 180, and they're all the same, indicating that it's an equilateral triangle. Okay, so we're dealing with a triangle again. We know triangles add up to 180 degrees. We know two of the angles, but we don't know one of them. So let's call this A1, A2, and A3. So we know A1 plus A2 plus A3, adding up all of our angles, that should equal 180 degrees. Well, A1 is 30 degrees. A2, we don't know what that is. We're trying to figure that out. That's our theta, and instead of A2, I'm actually just going to write theta. This theta is just the symbol to represent an angle. It's kind of like an O with a line through it, plus A3, which was 25 degrees. That equals 180 degrees. So theta is going to be 180, and we're going to move the 25 and the 30 over. So we're going to subtract it because we want to get it out of the way. So 180 minus 25, let's see, that's 155, minus 30, that's going to be 125 degrees. So this is going to be an obtuse angle because this angle here, theta, is more than 90 degrees. It's kind of stretching beyond that perpendicular part. Okay, classify each angle as obtuse, acute, or reflexive. So the angle here on the left indicated is called alpha. It's kind of like you know those fish you used to draw in elementary school? That was horrible. That was terrible. Okay, so kind of look like that, and then the tail, right? Kind of looks like that, except it doesn't have the tail, so it's just kind of a part of a fish. I don't know, it always kind of reminds me of that. And gamma, this symbol over here, is kind of like a vertical version of that. Beta, these are all just Greek parts of the alphabet, or parts of the Greek alphabet letters, right? And beta is just like a B with an extra long, like, vertical leg. Okay, so it doesn't matter what you call your angle as long as it's some symbol that you can kind of um, like kind of distinguish. So this angle right here, they're asking if it's obtuse, acute, or reflexive. This angle is going to be acute because remember, acute angles are always less than 90 degrees. And the way I think about it is acute angles are always kind of like mouths, like an alligator. So if you imagine teeth right here kind of chomping on something, if this was an alligator, this would be an acute alligator. So all alligators are acute because the angle between their jaws, right, these two legs, is less than 90. So if you see an alligator shape, it's always acute. Okay, obtuse is always less than 180, so it's less than a straight line, but it's more than 90 degrees. So this beta here, I'm going to write acute. This beta here, this symbol beta, it's going to be, all right, obtuse. Because it's not reflexive, it's not more than a line, not more than 180, but it's less than 180 and it's more than 90 degrees. So it's not acute, because acute would be this alligator shape. If you saw an alligator whose jaws look like that, I would be pretty worried. Okay, and gamma, I'll just write the symbol here. Gamma is, okay, gamma is going to be reflexive because it's more than a straight line. It kind of extends beyond that, right? So it's not obtuse because it's more than 180 degrees. Obviously, it's not acute because if this was your alligator here going the opposite way, that would be even more frightening than the obtuse one. Okay, last kind of couple questions here. Determine whether each triangle is isosceles, equilateral, or scalene. So, like I said, we all know that the angles of triangles add to 180. So if this is 70, this is 40, we're going to go 180 minus 70 minus 40. That's going to be 70 degrees. So we know this one's going to be 70 degrees. And since these two are the same length, that means we have an isosceles triangle. Or sorry, these two are the same, bless me, these two are the same angle, we have an isosceles triangle. So if these two are the same angle, that means that these two lengths are also the same. So it's going to be an isosceles triangle. So I'll just write here, isosceles, always kind of weird spelling. Okay, this one here, well, we see that this is 5, this is 3, and this is 4. So nothing's really kind of correlating, everything's different. And every time you see that, that's going to be a scalene triangle. Okay, see here we have a single line, single line, single line going through every single leg. So this is going to be equilateral. Hopefully you're starting to see these patterns. If it's equilateral, all the angles are the same and all the side lengths are the same. For this one, 2 of the side lengths are the same because there's 1 line through 2 of the legs and 2 lines through 1 of the legs. So these 2 lengths are the same, but this longer one, it's not the same. So it's not going to be equilateral like the one next to it. It's also going to be isosceles. Oh, isosceles. Isosceles. Perfect. Okay, so that's kind of the properties of triangles. It's kind of the basics. Learning the different types of triangles, the different types of angles. We know that now the angles in a triangle add up to 180. These are all super important properties of just math in general and trigonometry. It's not like some basic thing that's not important. It's kind of like the basis of all trigonometry that you're going to do. So if you can master this, that's a huge deal. You should be proud of yourself. And yeah, just if you didn't understand something, go back in the video and watch it again or drop a comment, shoot me a message or whatever it is. And I'm here for you guys. I hope this one helped, and I'll see you soon.